So the next topic is the AsyncTask framework. We'll come back later and talk about the Hammer framework in more detail, but AsyncTask comes first because we're focusing on that one for the purposes of what you need to do for the next assignment. So recall that this allows the apps to perform background operations in one or more threads and then publish the results to the user interface thread without directly manipulating messages, threads, runnables, or handlers. Okay, so let's talk about what is entailed here. The classes in the Hammer framework, which we'll talk about later, are loosely connected. So when you look at these classes, you look at message, handler, runnable, message queue, looper, thread, etc. It's not really clear just by looking at them that they belong together. So you have to know how the pieces fit together. Now, for very simple use cases, this is great. If you just have a thread and it's going to do something like, do some computation in the background and it wants to send the information to the UI thread to display it, it's really easy to do that. So for very, very simple use cases, it works okay. So if a background thread posts a runnable to the UI thread and the UI thread dispatches the run hook method of the runnable to do something, that's pretty much a piece of cake. However, there's some downsides with the Hammer framework. And in some sense, its simplicity is its own worst enemy in a way. One thing that you have to be aware of is if you're going to use it effectively, you have to understand the patterns that it embodies. So it embodies essentially the command processor pattern. That's what the posting runnables thing is. And it implements a simple variant of the so-called active object pattern. And that's what sending a message on a handler does. So there's a couple of patterns, and you really sort of have to know something about those patterns in order to use the pieces correctly. It's also a bit tedious and error-prone to use, especially if you start sending messages. There's some subtleties about the life cycle of those messages. There's a callback hook method called handle message, and the message itself only lives for the duration of that callback. If you want it to live longer, you have to do some extra things to save its state, so it's a little tricky to program correctly. Moreover, all the communication between the threads, anytime you want to post anything or send anything, you have to do that explicitly. You have to write code that sends a message or posts a runnable. Not the end of the world, but it's extra work. And the other thing is that any kind of pre or post processing that you want to have before you start to run things in the background and after things are done have to be handled explicitly. So stuff like starting and stopping a process dialog box has to be programmed by you very carefully to make sure that that runs in the user interface thread and then have the computations run in the background. So you've got some extra work to do. Once again, whenever the mechanism of the framework is simple, it puts more onus on the app developer to follow the rules properly. Something else that's a deficiency, you can't scale the performance up transparently. There's no way to auto-scale the number of threads that process requests with the Hammer framework. You have to write those threads. You have to spawn them as a pool. You have to manage them as a pool. You have to do all that work on your own. In contrast, AsyncTask provides a bunch of classes that are more strongly connected. And as you'll see here, what that really means is that there's an abstraction called the AsyncTask that encapsulates all these other lower level details that are otherwise exposed to you with the Hammer framework. So the Hammer framework gives you a bunch of pieces. The AsyncTask kind of bundles them together in a cleaner facade. In fact, that's really what it is. It's the facade pattern. It hides the complex framework interactions and structure and callbacks and functionality within a framework that you then work with in a much more concise way. So the facade pattern is just a pattern that allows you to encapsulate complex stuff within a simpler interface. Another example of the facade pattern that you've probably used before if you've ever done any systems programming is the Windows or Linux or Unix system call API, which is a facade that shields you from the ridiculous complexity of the operating system kernel and all of its management of hardware resources behind a simpler API. Of course, that API has lots of methods in it or functions, but it's a lot simpler than trying to program at the kernel level directly. One of the things that makes it simpler to use the AsyncTask framework is the surface area is smaller. And that's because it bundles things together into a single class where you can go and look and see what that class does, rather than having to have 4 or 5 different classes that you have to work on. So it allows you to focus on the what, not the how, whereas the Hammer framework has a lot of how involved in making it work. One of the things you can do is you can use concurrency without directly manipulating threads, handlers, messages, or runnables. And the way it does this is by using something called the template method pattern. You're probably familiar with the template method pattern. That pattern allows you to define steps in an algorithm that are going to be delegated to subclasses or a subclass to override those steps. So you can do customization in a very stylized and convenient to extend way. And we'll see how that works in a second. The hook methods that are used provide you with opportunities to override the behaviors of your async task object in terms of well-defined points in the life cycle of the async task. And in particular, you can perform pre-processing in the user interface thread, post-processing in the user interface thread, and you can also have well-defined hooks to communicate from the background thread or threads to the user interface thread in a very stylized, convenient, and easy-to-use manner. And the whole thing works by hook methods that you can selectively override and then ensure get called back at the right time by the framework. And I'll explain how all that stuff works. That's actually very important to understand for your programming assignment. Another neat thing about the AsyncTask framework is that you can scale up the performance transparently. And the way you do this is you can give it a thread pool. And this thread pool can be specified and then given to the async task when you invoke some of its methods. There's a method called execute on executor. And when you call execute on executor, you can pass in a thread pool of some variant, and that will then be used to run async tasks in background threads. In particular, you can use the Java executor framework to do this. So you can pass in an executor, which could be an executor service instance, which would typically be some variant of thread pool executor, like the fixed size thread pool or cache thread pool. You can also use a fork join pool. There's a bunch of things you can pass in order to be able to customize the scalability of an async task by giving it a thread pool that can run things in multiple cores without having to change your application code, which is really, really cool. Okay, so that's a quick overview of the async task framework at a high level. We'll then start going successively into the details of what its methods do and how to program it in just a second. So now that you know a little bit about the concept of async task, let's start diving into what methods it provides. And you'll see that it has a lot of methods. At first they look complicated, but they're actually quite stylized. So once you get the gist of it, it's easy to use. There are 2 general types of methods in async task. One are public methods that can be invoked by applications. And here they are. The execute method is used to execute an async task instance with the specified parameters, which, as you can see, are what are called var_arg parameters. You can have multiple parameters or just one. And what async task does when you call execute is it runs the async task. If there's multiple async task instances, all of which call execute around the same time, then execute runs each of those async tasks serially, in other words, one at a time, in a background thread within a process. So async task by default will run stuff in the background so you can block and do long duration operations, but it doesn't run them in parallel by default. If you want to run things in parallel, you need to use this method, execute on executor. And this is really important because this is the one you'll need to use for your assignment. So what this does is it executes the task with the specified parameters on the specified executor. And this allows you to be able to have multiple async tasks run concurrently in a pool of threads within a process. And shortly I'll show you how, by default, the executor that's used, there's one that comes out of the box called thread pool executor. I'll show you how that's defined. And it basically has a pool of threads that are given a default thread pool size, and you can kind of grow the pool up to a little bit if you have bursts of activity. There's also a method called execute where you just give it a runnable, and this is just a front end to the underlying executor. It doesn't really do anything interesting, and we don't use it. And then the other method that can be invoked by an app is called cancel. And cancel basically tells the background computation associated with this async task, we don't want you to keep running, shut yourself down, please. Now, cancellation is like thread interrupts where it's voluntary, but it's a way of trying to stop things from running. And you can either tell it to interrupt it if it's running or not. So if you pass in true, that'll really try to shut down the background computation. Otherwise, it'll just say, I don't care about the result of this background computation, even though I'm not trying to shut it down. There are also a whole pile of protected hook methods which can be overridden by applications, and then they'll be invoked by the AsyncTask framework at the appropriate time. And as we'll see, the AsyncTask framework will invoke these hook methods, which we'll talk about in a second, at different points of time and in different thread contexts. So some of these methods are run in the user interface thread, like on pre-execute and on post-execute. Other methods are run in the background thread, like do in background, and so on and so forth. So we'll talk about all these different methods and how they work. On pre-execute is a hook that's called back automatically by the AsyncTask framework in the user interface thread prior to any other processing taking place on that async task. So it's basically a way of saying, before you start running in the background, do this thing. And this thing is typically stuff like, start a dialogue with the user or put up a spinner that tells how progress is going to go. And the reason that you need to do that in the user interface thread is because you can't do the UI operations in a background thread. So that's why we have this hook. It's to do things before the threads start to run in the background. Do in background must be overridden. It's the one and only hook method that has to be overridden, otherwise nothing useful would happen. And this performs a computation in the background thread on the parameters that are passed to it. And we'll talk about how those parameters show up here in just a second. So this is what actually does the work. And keep in mind that do in background cannot directly talk to the user interface toolkit components. If it wants to talk to the user interface toolkit components, it does it by basically having this hook method, ensuring that this hook method gets called back. And if the do in background method calls publish progress, that will, which runs in the background, that'll bundle up the publish progress parameters, send them over transparently to the user interface thread where the on progress update hook method gets called back. So on progress update gets called back in the UI thread when the background thread calls publish progress. So that's how the background thread can talk to the user interface thread, or a background thread can talk to the user interface thread. And you often use this to convey incremental results. Like let's say you're downloading a large file and you want to be able to give someone a progress bar that shows how far along you're going. So you're running in the background, downloading a chunk of the file, downloading a chunk of the file, downloading a chunk of the file. After every chunk has been downloaded, you can say publish progress and give a percentage of completion integer that will then be sent over to the UI thread, and in the on progress update method, you could update the progress bar to indicate how far along you are. So that's what you could do with that. There's also another hook method called on post execute. When do in background finishes, it returns a result, and that result is passed to on post execute. And that will then run in the UI thread after do in background finishes. And you typically use this to indicate that something is done. For example, you might cancel the progress dialog in the on post execute method because you're finished doing the download or whatever. That's what gets called back. On post execute gets called back if things work. If something fails and or the async task is canceled, then the onCanceled hook method gets called back. And that will indicate that things have finished non-successfully, and you may want to do something different in that case. You might want to print some kind of error message or pop up a toast that says download canceled or whatever, and that would be a way to do that with onCanceled. Okay, so those are the hook methods. Let's talk about how you override them. So AsyncTask must be extended, and there's various ways to do that, and you have to override one or more of its hook methods. So let's see how this works. So here's AsyncTask, and then here might be a specific instance of AsyncTask called ImageDownloadTask. The doInBackground method must be overridden. If you don't override that, nothing useful gets done. So you have to override that. That's a protected method that has no default implementation, so it's abstract. So you have to override it. That method has to be overridden in the subclass. Execute can only be called once per instance of AsyncTask, and you typically call this in the UI thread to start the ball rolling. It's implemented internally as a variant of the template method pattern, so that means it'll end up having these hook methods called back at the right point and the right time, the right context to do things along the way. So it's template method. It has the skeleton of an algorithm with hooks deferred to subclasses for overriding. Yes? So the question was, what happens if you call the execute method in some other thread other than the main thread? So you're not supposed to do that. If you do that, it might work. I think in that particular case, it will end up, let's see. I think it'll end up dispatching things back in the user interface thread no matter what. We'll look at the implementation, probably not this class, but in a future class, we'll take a look at the implementation of AsyncTask, and you'll see how it's designed. I'm pretty sure it'll go back to the user interface thread for that, but it might not. It might come back in the thread that's the background thread, but it's generally not a good idea to use the AsyncTask for anything other than the user interface thread. And I think the documentation says words to that effect. How far they go to enforce that, I'm not sure, but you're not supposed to rely on it working in anything other than the UI thread. Executor and executor can be used to pass an executor along with the parameters, and that allows you to run multiple async tasks concurrently. We'll talk more about that in a second. When execute or execute on executor is called, the onPreExecute hook method is dispatched. By default, onPreExecute just does nothing. So you don't have to override it if you don't want to, but if you do, it'll get called before things start to run in the background. doInBackground does the stuff in the background. You might want to take a look at some of the interesting things about this. The interesting issue here is that doInBackground by default runs in the so-called background thread priority, which is a lower priority than the user interface thread priority. So if you don't like that, you'd have to explicitly change the thread priority in doInBackground before you let it continue to run, which you can do, but it doesn't do that by default. You can have onProgressUpdate called when the background thread running doInBackground calls publishProgress. That's how you communicate incremental results back to the UI thread. onPostExecute gets called when doInBackground is done and it returns a value that can be passed to that. And if you cancel the async task, then onCanceled will be dispatched. If onCanceled is called, then onPostExecute is not called, and vice versa. So if you're not canceled, onPostExecute is called. And onCanceled is not called, of course. If you are canceled, onCanceled is called, and onPostExecute is not called. So only one of those methods gets called. You can also call a method called isCanceled to check if you've been canceled. So the doInBackground method should probably check periodically if it's been canceled, because that's the way it knows it's been canceled. Much in the same way that if you have a regular Java thread and you check the thread interrupted flag, you can find out if you've been canceled. So it's basically voluntary cooperative shutdown. AsyncTask is also parameterized by 3 types, and these are very important to understand. And the first parameter is called params, and that indicates the type of work that's being done in the background. And so when you call execute or execute on executor, if params is non-null, then you would pass whatever type you want to give to the background thread. So let's say, for sake of argument, you were downloading a file with an async task. So, or downloading an image with an async task. You would probably make params be URL or string. And then when you called execute, you would pass in the string or URL version of the URL. And that would then get passed to do in background, and that would then process whatever URL you gave it. So it's a way for the UI thread to communicate what it wants done to the background thread. Progress indicates what you're going to do for incremental updates. That's often void because you often don't need to do this, but if you do, you could make it integer or long or string or whatever. And then result is whatever is the result of doing background, and that is passed to as a parameter to on post execute or on canceled. So that basically is a way to communicate from the background thread back to the on post execute hook method or on canceled hook method when things are done. So here's a very simple example that illustrates how this might work. This is a download task example. If you take a look at the documentation for async tasks, they show you this code or code like this. Here we're going to have an async task that's parameterized by a URI, just like a URL, which is the params type. Integer type is the type that's used to indicate the progress, and the long type is the result. So what we're going to do here is when you go ahead and execute this code, when you execute it and you give it a download URL, the doIn background method is called with the URL that you passed in. You download the file. Along the way, you could call publish progress, which would set the progress percentage indicator in the UI thread. And then when this thing is finished, it's going to return, say, the number of bytes downloaded as a long, and that will then come to the on post execute method, and it might print some kind of dialog or toast that indicates that we downloaded n bytes, something like that. And this is what actually starts everything going. This is the method that invokes the async task. You can see here we make an anonymous instance of an async task just to show that you can do that. If you make an anonymous instance of an async task, it's going to be very hard to cancel it. So if you need to cancel, then you want to make a real instance that you would store. But if you're just running it, you could do it like this. Okay, so that's the end of the async task framework